Safety is paramount for modern automotive design. Airbag is the default in any modern car. Also, more exotic systems like gaze tracking are getting well established. And millions are invested in the advanced driving assistance systems and LiDAR. Drive and Vision News organized a special workshop to discuss how next-generation lighting will help to improve the communication between road users and so enhance safety.
Over the past 4 decades, we've witnessed a remarkable shift from analog to digital photons, spearheaded by innovations like LEDs, OLEDs, mini-LEDs and micro-LEDs. These advancements, once confined to consumer electronics, are now entering and potentially revolutionizing automotive lighting. But why and how is this happening now?
We are fabricating the OLED, not LED, but organic LED. So what's the difference? The difference is, for example, it's for us, one device. It is one device. It's not made by several or hundreds of the LED. This is one OLED device. So it's a naturally area lighting source.
Cutting-edge display technologies commonplace in devices like TVs and smartphones are now making their way into automotive lighting designs. This integration opens up a world of possibilities for communication and safety enhancement on the road.
And OLED technology is used from your cell phone, your TV, so it's more easier to us to use some display technology to show you some information like this.
Imagine vehicles equipped with lighting systems that can convey important messages to the other drivers, like warning that the baby is on board or signaling about upcoming hazards or debris on the road. That information can come from sensors in the car or traffic info networks. We saw examples of personalized messaging and gesture animations, a new way to communicate with pedestrians or negotiate who will go first at a four-way junction. This prevents accidents. Though I'm not sure if creating light patterns to the music will distract others like in old TV series.
The advantage of OLED compared to other technologies like LED is that the light in an OLED is generated from the entire surface of the OLED. It's not a point source of light, it's actually an area source of light. And it's in fact the world's first area light source. The light is generated over the entire transparent electrode, uniformly, perfectly uniform and sharp edges. And because of that, we can create very beautiful homogeneous light images, like the light bars that you see currently on the backs of cars. But they can be composed of individually addressable segments that are sharp edged, so that you can also use that to generate different shapes, communicate with it, and do other things that you cannot do with LED.
A strong part of miniLED technology is high resolution. Okay, we are able to have single color LEDs. We are able to have RGB capability. We are able to have almost a screen feeling. Okay, and we are able to achieve a luminance of 1,000 candelas per square meter. Also, we are able to connect. If we are in a barbecue, we are able to connect with the music, and the rhythm of the music will be according with the lighting will be according with the rhythm of the music.
Optica members Zeus Micro-Optics recently changed its name to Focuslight Switzerland following a strategic acquisition. This allows them to scale up faster and enter new markets. They already won awards for advanced microlens arrays, as we saw in Munich.
Since 2017, we provide MLAs to the automotive industry, especially for decorative elements for light carpet applications. And since a couple of years, we also provide MLA technology for headlamp applications, for example, for the Lucid Air or for the Hyundai Genesis G90. And this has the potential to disrupt the automotive lighting industry with completely new design concepts that are enabled by MLA technology. So for the combination of these MLA products with micro-LED technology, for example, we see that dynamic lighting concepts with very small form factors, very slim designs, can enable completely new ways of imagining the fronts of cars, bringing emotions to the car industry and enabling completely new ways of futuristic fronts and cars.
As electric cars need to become more affordable, DBM Reflex is introducing injection-molded, single, free-form optical elements to bring down the price of luxury features.
We are thinking about free-form lenses. A free-form lens is a lens that has a special shape so that it projects the light in a predefined way. You can also project arrows, you can project shapes on the ground without using an MLA and without using a mask in the MLA. So the freeform lens has advantages and disadvantages. It's a simple system. You only need an LED and a freeform lens and you already have a projector. But on the other hand, the detailness that you can reach with an MLA, you cannot really reach it with the freeform lens. But we think it could be an interesting alternative for the automotive makers to show logos or symbols, patterns on the street. So we have here a small demonstrator where we have a simple system consisting of an LED and a freeform lens. The freeform lens looks like this. You don't really see the optics that is incorporated. If you look very carefully, you can see on the shape there's a little bit distraction. These are the optics. And when I switch it on, you can, for example, see in this case chevrons that can be projected on the street as a signal function for additional attention for the turn indicator.
Other Tier 1 manufacturers are also embracing these elements, whether through analog or digital design approaches.
With analog, you are restricted. You can put on or off at the LED, but with the digital photon, you can control all the lighting, also communication inside. You can make dynamic and many function inside. And yeah, I think the technology will go ahead also on the digital photons.
While most Asian markets are swiftly embracing digital advancements, Europe remains cautious, prioritizing functionality and regulatory compliance.
Displays, they are coming in lighting industry. In the past, it was no display, it was just LED, one light source, and you do one function. Now you have different light source, you have 1,000, 10,000. We talk about pitch, 10 millimeters, 4 millimeters, 1 millimeters, and we are thinking of what is the best pitch. And what we have seen today, the best pitch could be between 1 and 4 millimeters, but it's really depends about what we want to do with the display. And for the moment in China, nobody has thought about it. They do display, but they don't know what to do. So what we have to do in Europe is to think about why we want a display. And when we know why we want a display, it will be easier to design it.
The synergy between technology and regulation will shape how fast these advancements unfold. Those who move first will clearly have an advantage.